So, hey Tatiana, what is additive manufacturing?
I am so glad you asked. Additive manufacturing is this new disruptive technology.
False.
So, additive manufacturing has been around for 40 years, and there is a bunch of materials that you can do additive manufacturing with. So clearly, ceramics, metal, plastic, wax, sand, concrete, a lot of stuff. And you can print things that are so tiny they can go through the eye of a needle, and you can 3D print your own house, or you can print an organ or like a medical tissue, body tissue to replace something. So the possibilities are really endless. And that is the real reason why there is so much attention towards that technology. It's not because it's new, it's because of the things that you can do with it, right? So how does it work? I mean, so when we think about making stuff, producing something like a car, building a house, or building a bridge, we usually think about big production facilities, complex machines, and solid materials like steel, concrete, stone, wood, or whatever there is. But what we're really doing, what's happening, we take a big chunk of something, a big chunk of material, and we are taking bits of it away to bring it into a shape that we want, right? So that is subtractive manufacturing. So you take something big and then you remove parts of it to bring it into shape. Additive manufacturing is a completely opposite concept. So what's behind it? Instead of taking bits of material away from a big chunk, you add material, layer on top of a layer on top of a layer until you got to the shape where you want it. So everything starts with a digital design file, and then you just break it into layers, cross-sectional layers, and then a 3D printer puts one layer on top of the next layer on top of the next layer up to the very top until you get to the shape that you want it.
Yeah. So now we're going to explore the 7 exciting, you're going to have to click, exciting, there you go, and categories of additive manufacturing.
Oh, wow.
Maybe I click on this one. All right, excellent.
7, that is so many.
It's so many, it's so many. So we've got vat, photo, polymerism. Ooh.
We've got material extrusion,
Material jetting,
binder jetting,
powder bed fusion,
direct energy deposition.
There you go. And last but not least, sheet lamination.
Exciting.
Super exciting. Wow. I bet you want to know more. Great, we're going to tell you. All right, so we actually don't have so much time, and I don't think you're really that interested. So we're only going to talk about 3 of them today. So these are the most commonly used, the most common forms of 3D printing we see now from our research. And mind you, we don't work in this industry at all. So let's go into vat photopolymerism, which is a process for plastics where it's cured with some sort of light source, also known as stereolithography, or SLA. So this is where this is the first technology that was invented for 3D printing. So here we have some sort of light source that sends a beam and hits some sort of vat of goo. All right, so this is how it works. So we've got a light source hits the vat of goo, and then it solidifies the goo or resin. So here you've got a light source and you've got this deep vat, and so as each layer comes down, the light source hits it, it drops down into the vat, and eventually you end up with your finished product. So we'll take a look at that. So this is a vat of some sort of resiny. It resonates with me. So it does this again and again. So each layer then goes, it wipes the layer down, drops it down, and then it hits it again with another layer. So slowly, slowly, slowly it builds it downwards. Then when it's finished, it's really difficult to see, but okay. When it's finished, it raises up out of the goo, which is then all the structural material is cleared away on the side, so to keep it from tipping over. All the structural material is cleared away, and obviously the goo is also cleaned away. And this is also how they create all the characters in Westworld. So that's very interesting. All right, next.
Next, material extrusion. So material extrusion is really not a new thing. This has been around since the 80s. And this technology is also known as fused deposition modeling, short FDM. So this is really what everybody has seen. This is this plastic thing that gets melted, and then it puts layer on top of a layer on top of a layer until you create stuff. And so the technology has been around since the 80s, and that was the reason why those 3D printers got so affordable. Now, who here has used a 3D printer, like a maker bot?
Like a baker bot?
Yeah. Oh yeah, very good. Yeah. So who owns one? Nice. Right? Yeah. Very good. So why do you guys own one if you do not work?
So we were,
And so we were thinking, yeah, like back in the 80s, this technology is going to change our life because we're never going to go shopping for tools or whatever. We're just going to print them at home.
yeah, so we were all, we're going to have the ability to make everything that we need for our houses at home. It's going to be great. But it turns out we only really grew the ability to create really useless objects. Just a bunch of crap. And that's, we can only print really nice stuff when the machine decides to work, when, we're at home trying to make it ourselves. So, but there are some industrial applications of this technology as well. So, and it's, we can use it, but it's not very precise, really at all. So if you need something that needs to be very precise, this is not the correct method to use. And we can see that here. If we do the fused deposition modeling versus the stereolithography, you can definitely see the differences in the quality of the products. And here you can see another one. So same design, completely different processes for creating. All right, so there is one application where it could actually be interesting when you somehow weirdly don't need such accuracy. You need to build a building very quickly. You need a lot of housing very quickly. So now it's being used to 3D print houses. And this is actually, I think, a practical application. So in a refugee type situation or a natural disaster type situation, this technology is really quite useful.
Or if your family grows very fast and builds an extra room in your house.
Extra rooms.
Practical.
All right, and now we're going to talk about powder bed fusion.
What is that?
Exciting stuff. All right, so powder bed fusion is a method where you use a lasers to fuse metal powder together, or metal or plastics. So if you use it with plastics, it's called selective laser. I want to say sinister, but that's not it. It's sintering. What is it?
Sintering.
Thank you. Sintering, all right. And if it's metal, then it's direct metal laser sintering. And there are some others, but I can't pronounce them, and we're not going to get into it tonight. All right, so this is an artist's interpretation of what this direct metal laser sintering is. And so here we've got, just for those of you who don't know what this is a metal powder. So it's incredibly toxic, dangerous material. And so there's metal powder, and then it's hit with a laser, and then you end up with this piece at the end. But we'll talk about how that actually works. So what happens is you've got a 3D printer, and it's got this metal powder, and it lays a layer of the metal powder across. Then it's shot with a laser, pew pew, and it then melts the metal, and it fuses it together. And so this happens again and again. It's a layer of powder wiped across, and then the laser hits it, fuses it together over and over and over again. So you end up with your part. And parts that look like this, and these are structurally strong, and I think you have to do some other heat thing afterwards, and there's a whole bunch of treatments and things, but you end up with actual usable production parts that can hold heat, and they're not the 3D printed cup. So we could also use it for fine metals as well, so creating jewelry, and we could use it to create these almost impossible type objects. And we can make things with incredible precision and just in minute scale.
I mean, I don't really know. Maybe they just had a really big match. So
it's also possible.
Yeah.
And then so we can also use the same application for plastics. So it's a similar application for plastics as well, obviously without the metal powder, but heat fusing the plastic particles together. But the application that I'm most excited about with this technology, it's gotta be the shoes, guys. It's gotta be the shoes. Yeah.
I mean, like, these shoes look absolutely ridiculous.
They're so great. Look at those.
And I can just bet $10 that the day you wear these shoes, you're gonna end up breaking a leg.
Oh, breaking my leg, but that doesn't matter. Why? They 3D print casts, that's right. Customized just for me. So, but I think that actually medical applications are probably the greatest result of 3D printing development. So having to have everything, I mean, if you want to talk about customization and low, this is definitely the best place to do it.
Now, let's have a technical
Okay.
moment. So, where does additive manufacturing actually make sense? When you are at a remote location and something breaks down and you need spare parts and you don't have them and there is no way Amazon Prime is going to deliver that same day, so you just print them all by yourself. So some other applications include medical devices or rapid prototyping, or basically anything where you have really low production numbers or very high scale of customization.
So now it's something like over 80% of all hearing aids are 3D printed.
Oh, sorry, can you repeat that? Right. So there is a lot of stuff that you can do with additive manufacturing, and you are going to hear about it more from our speakers. Right.
So additive manufacturing means that we can create more sophisticated and beautiful things, and that we can create tiny things that live inside of our body, and we can even 3D print food.
But that is not the reason why this is so exciting. Much more important is that it'll entirely change the way we design, make, and use things. And this is why there's so much attention around that topic, and this is why we're here tonight. Right.
So I'm excited to learn more from everyone. So, all right, and
Ta-da!